This is my write-up on Kernel Adventures Part 2. When exploiting a kernel, there are typically two ways that you're interacting with the kernel, either by a kernel driver or a syscall. So, in this case, we are exploiting a patched-in syscall. We have a magic user struct. This struct is 144 bytes in size, and the struct contains details of each user, including the username and password and UID. It also contains a pointer to a list. This children pointer seems to contain pointers to more users. Analysis of the do-add function. It will first check if the username passed is already a username. If it is, it'll return -e exists, meaning file exists. After that, it'll set main list slot equal to the first empty slot in the magic users array. It'll set index equal to whatever locate user by ID returns. Note, magic users is an array of pointers to the magic user struct, each pointing to a structure representing a magic user, and initialized with all elements set to null. Me is now a struct pointer for struct magic user, pointing to whatever index in magic users. Child slot will be equal to the next empty slot unless locate empty returns -1. New user will become a pointer to memory, returned by kzalloc, size of struct magic user, passing in gfp kernel, unless kzalloc returns null. If so, it'll return mem. The struct members will then be filled out and written into memory. If new user children is null, it'll k-free new user and return mem. Magic users and children arrays will both be updated with the data returned by the new user struct. After that, rep will be equal to the next ID, which is the UID. After that, next ID will be incremented and next ID will be returned. The doEdit function. My index will be equal to the current user ID. If locate user by ID returns -1, it'll return ent, meaning no such file or directory. Me will be equal to the current magic user, and if the usernames are equal, then child will be equal to me. It'll string compare me username, so the username passed into the function. If they match, then child will become equal to me, which is the current magic user. Otherwise, it'll set index to locate user by name, passing in the username passed to the function. If -1 is returned, eperm will be thrown, meaning operation not permitted, and child will become equal to me, children index. Finally, string compare password passed the function into the child password member of the magic user struct. The do switch function. My index will be set to the current user ID. If my index is -1, ent will be thrown. Me will be equal to the current me will be equal to the current magic user. String compare gets called on the current username and the username gets passed to the function. If the same, return 0. Since this section is heavily commented, I'll move down. This section is a mouthful. It's just explaining what this is doing. Pause here and read this if you'd like. The delete user function. This will loop 64 times and check each child in the array of children. If it's null, it'll continue. If not, it'll do recursion and set user child I to null, and then k-free children and user. The do delete function. It'll grab my index by using locate user by ID on the current user ID. If the function returns -1, it'll return ent. If not, it'll continue. me gets set to the current magic user, and index gets set to locate user by name, passing in the first argument to the function, which is the username, to delete. If index is equal to -1, it'll return eperm. Afterwards, global index will be set to the index of the username being deleted in the magic users array. Child will be set to me_children index, and child will be then sent off to delete user. And children index of current magic user and the user being deleted will be nulled out. So now the vulnerability analysis. So there's a wraparound within the doAdd function and not in the doDelete function. I didn't mean to say that, but doDelete never decrements next ID. Since doDelete never decrements next ID, we can just make next ID wraparound by adding and deleting a bunch of times. As we know, next ID is just a KUIDT, which is a kernel type meaning unsigned short. We can eventually make this wraparound to 0 and switch to the user that wrapped around and get root. Here we see next ID being incremented, and then the doDelete function, it's never decremented. So we have a modified run.sh script, which will basically just end up putting our exploit on the box and then running the system with Keymu. And here's our exploit. We have a wrapper for doAdd, doEdit, doDelete, and doSwitch. And we have a pretty short exploit here in the main function. We have a for loop here that loops 65,535 times. And it'll basically just add and delete a bunch of times until int user is equal to 65,599, which is the user that eventually wraps around. And then it'll do switch. It'll pass in the creds, and then we just exec ve bin bash in order to pop a root shell. We get a root shell. Thank you for watching.
He hit the ground, the sound was splat, his blood went spurting high. His comrades, they were heard to say, a hell of a way to die. He lay there rolling round in the welter of his gore, and he ain't gonna jump no